Right, let's go ahead and take a look at the Three Sisters drawing package. And when I say a drawing package, this is one drawing file. This is a single drawing file. It is not 25 files. It is a single file. And if you look down here at the bottom, each of these tabs is a page. So if you're one of those people that you're just used to having 50 drawing files, you're used to having multiple drawing files, think about it this way. Each of these tabs represents a file. But nobody in business or anywhere wants to open up your folder containing 50 different drawings and look at them individually. You want to see how they relate to everything else and the subassembly. So what we have here is a drawing package flow. So I'm going over right now the drawing package requirements for the Three Sisters and the 32 tall. These are the same requirements, the same flow. You want A size paper, 8.5 by 11. And this is the format that I'm looking for. This is the default A size in my SolidWorks install. Okay, I want this mess. I want this. And here's the thing about sheet format. You don't get to choose your sheet format. The company you work for crams that sheet format down your throat, and that's what you use, and that's what I'm doing here. This is the worst sheet format that exists. So if you can make your stuff look good in this, you can make it look good anywhere. Okay, A-size paper. The other reason we're using A-size paper is a lot of students use this and some other drawing packages and assignments in this class and my other class as examples of their work when they're applying for an internship and a job. And companies like this. They like the flow for good reason. This is a very good way of communicating your parts and assemblies and final project to someone else. The very first page is your main assembly, shaded with edges, as big as you can get it without touching anything. Okay, there's still some white space here. Now, yeah, there's some unused white space to the right and to the left, but this particular student centered it up pretty good, and it's as big as we can get it. The next page is the explode. I'll be going over explodes in a different video, but this is the main subassembly exploded into its subassemblies. The student chose 4 subassemblies. He or she named them A, B, C, and D. And they are labeled or ballooned with the corresponding letter. You could use a number if you want. This particular student chose to use letters. That's fine. And that's all it is. Notice that there are no callouts on the hardware. The hardware just sort of exists. Okay? So the next page, so the first page is the main assembly. The next page is the main assembly exploded, also shaded with edges. The next page is the isometric view of the first subassembly. So in this case, this is subassembly A. My next page is going to be an isometric view, shaded with edges, of subassembly A. My next page will be the exploded view of subassembly A, and in this case, it's just 2 parts. But they are ballooned, they're labeled, and this particular student chose to use numbers for their parts, and they are labeled part 1 and part 2. So my next page is the very first part of the very first subassembly. And in this case, it's the flywheel, and he called this subassembly A part 1. I wouldn't call it that. I would call it A1, personally, A-1. For your flywheel, because some of you are going to get super tricky with your flywheel, you do not need to dimension the inside. That would be a lifetime of regret in this one, okay? I just want the side view showing the overall diameter and the overall thickness, which this particular student did not do, and the cutout depth, okay? So this view, and it's evident on your drawing package which one I'm talking about. But this will save you a day, okay? You don't need to dimension the inside of this. My next part, or my next page, is going to be the next part. Notice also, in terms of flow, when you get to the part, you will always have a small, doesn't have to be scaled, it doesn't have to be the same scale as your front, top, right side, whatever, shaded with edges in the upper right-hand corner. You're always going to have an isometric view. And then the views that you have here should be as large as they can be, and you only need the views that you need to convey the dimensions that need to be conveyed. In this case, 2 views. In this case, 2 views, plus the ISO up here, shaded with edges. Notice that these are not shaded with edges. These are, it's basically just lines, and you may or may not use hidden lines visible. It depends on how to best represent your part. This particular student, I think, messed up. I would probably never give both of these dimensions. I would be more comfortable with an overall and one of these. Let's see, next page, next subassembly, and that whole process starts all over again. Next subassembly, shaded with edges. Next subassembly, exploded, shaded with edges, and ballooned. Notice that the hardware doesn't exist, it just floats. Next page, first part of this subassembly. So in this case, this is subassembly B, part 1, and fully dimensioned. Isometric view, upper right-hand corner, wireframe for everything else. And it just keeps going like that until you're done. Okay. So this finishes the requirements. Now, here's some mistakes people make. And they don't think it's a mistake, they think it's a great idea. You never want to over-dimension things. You want to fully dimension things. Never, ever import all dimensions. It's a waste of time. It's going to import dimensions that you don't need, and it's going to leave out dimensions that you do need. It's not a magical button. It's a waste of time. You have a drawing package that has every critical dimension that's required because you use them to draw the parts. Okay? Don't let SOLIDWORKS assume it's going to do the right stuff, because it never does. Using symmetry to your advantage. That's a whole nother lecture, which we'll have. But don't forget to use center lines. Make sure you are using all the required views to fully dimension the part. Okay, if there's a feature, you need to show it, and that feature needs to be normal to the viewer. So in this case, like we had talked about this crank disc, here's that hole that was in question last time, and notice that it's dimensioned normal to the viewer. You do not dimension hidden lines. So you're going to have multiple views. This particular student, we'll say this is let's say this is the front view, this is the right view, and this is the top view. Now, a lot of you are going to import front, top, and right side because that's been sort of beat into your brain over the course of several years in terms of drafting. Keep in mind that the front, top, and right side view is a normal for a lot of parts. What's required to show all the features? That's not the case. You may have to show left, bottom, right side. You know, it depends. From part to part, it depends. There is no cookie cutter answer for that. You have to look at the part and determine what views are required. Make sure you rename these tabs so that it reflects what's there so I can find it. You don't need dimensions on your personal flywheel, just the overall. Do not make drawings of hardware or purchased parts. It's a waste of time. Those already exist. We buy them. I can get those drawings from McMaster-Carr. Also, don't waste your time in this with the bill of materials. I know that there's a button for bill of materials. We all know there's a button for bill of materials, and I don't care that you know how to push the bill of materials button. Let's just leave the bill of materials out of this. Okay? All right. This already got too long. I'll have to edit this down.